there are no space there. So if that's the case, then everything will be here in this Google Classroom. So you can join us as much as possible, at least twice a day. Check your emails, okay? All right, then let's start the session. So first, in today's session, I'm going to discuss the general idea of data structures and algorithms. So what are we going to discuss in this lecture series? And what is the course capsule, and what is the evaluation methods, and what else? Reference books, those things we will cover in today's session. Right, let's move on with it. Right, so first of all, these are the reference books that I have used. Yeah, you can check for the PDF versions of these books. They are there. And introduction to algorithms might be a little bit harder for you, since this is the first algorithmic course that you are learning. But however, these are good reads, so go and read your do your references in here. Other than that, yeah, I will always do the practicals separately, but however, there are some coding parts in the lecture series as well, in the lectures as well. So I hope if you have any questions throughout the class, you can ask, or you can use the chat to communicate with me. You can stop me and ask the question, okay? So no need to worry. I think ICT students already know that, but ENT students, you also don't have to worry. If you don't understand anything, you can stop me and ask, okay? Right, so this is the original evaluation criteria. We are going to cover 40% of the final marks from using the assessments, CS, continuous assessments. We are going to do a mini project, 10 for assignments and 10 for class tests. The continuous assessment portion might change a little bit from year to year. It doesn't matter, however, 40% will be calculated from the CAs. And then from the end semester examination, we have allocated 60%. So 60 will be taken from the end exam, and 40 will be taken from the continuous assessments. Okay. Right, so these are the course objectives. So these are the things that you have to know at the end of the course, okay? At the end of the course, the student should be able to use iterative and recursive techniques to design and implement elementary algorithms. Second one, analyze the time complexity of elementary algorithms and justify the complexity of the above abstract data type implementations. Incorporate abstract data types and associated implementations appropriately into, so this should be associate implementations appropriately into program solutions. Fourth one, demonstrate the use of data structures in computer programs. Use of data structures. Where do data structures use and how to use it, right? Demonstrate the application of fundamental data structures in solving real life problems. So at the end, basically, these are the most important things here. At the end, you have to know, to solve a real world problem, what is the most suitable data structure to be used. Right? Here, we are going to learn multiple different data structures. And the purpose of each of these data structures are different. Okay, so you have to know, to solve a real world problem, what is the best data structure to use. Okay. Right. So then after that, yeah, I will discuss the lesson plan as well. Yes, introduction. In the introduction section, we are going to discuss the data types, data abstraction, abstract data types, and a little bit about algorithms. Then in the second lecture, we are going to discuss the algorithm analysis, common functions and their growth rates. You will learn what these growth rates means, right? The big O notation, comparative analysis, role of data structure in software development and recursion. So basically in the algorithm analysis, we are discussing how to evaluate two algorithms written for the same purpose. එකම දේට එකම ටාස්ක් එකක් සඳහා ලියපු ඇල්ගොරිතම් දෙකක් කම්පෙයාර් කරන්න කොහොමද කියන එක තමයි අපි ඇල්ගොරිතම් ඇනලිසිස් කියලා කියන්නේ. How do we analyze an algorithm? Okay, so there we analyze them or we compare them using the time complexity and the space. Time complexity and space complexity. ඒ කියන්නේ මේ algorithm එක run කරන්න කොච්චර time එකක් යනවද කියන එක. It is not just the time. How does the time changes with the number of items changes? You will get into the idea further on when we discuss that in the next lecture. However, it is about comparing multiple algorithms against each other. Okay. Then the first kind of a data structure comes with arrays. So we can say array is a data structure. The most basic data structure is an array. I'm pretty sure that you have learned arrays in your programming class, right? So here also we will discuss a little bit about arrays and how the array and memory and array dimensions. There are one-dimensional arrays, two-dimensional arrays, and multi-dimensional arrays. We will discuss those as well. And then the fourth one, lists. Linked lists and array-based lists. We will learn those. Then in the fifth one, lists. Singly linked list, doubly linked list, linear lists, and circular lists. Again, in the today's session, in future slides, I will explain what these lists are. Then we talk about stacks. Stack is again another data structure. And we can implement stacks using lists and using arrays. Right? We can implement stacks using lists and arrays. So getting a thorough idea about arrays and lists are important. So out of all these things, arrays and lists are the most important things that we have to discuss here. Because without knowing lists or arrays, we cannot go beyond that. We cannot move forward if we don't know lists and arrays. Yes, any question? Oh, maybe a mistake. Okay, so to learn stacks, you need to know arrays and lists. To learn queues, again, you need to know arrays and lists, right? That is the next data structure. And we'll be learning trees, binary search trees, AVS trees. So these are the data structures until AVL trees. Those are the data structures that we are going to discuss. Then we have few algorithms. We have graphs as well. Sorry, I forgot. Graphs is also there. Graph is again another type of data structure. Then other than that, we are looking at searching sequential search, sequential search, binary search, and tree search, heaps and priority queues. We are discussing those things. Then sorting algorithms, bubble sort, heap sort, quick sort, bin sort, or selection sort. We will discuss few of these sorting algorithms, and normally I have always given an assignment for you guys to design a sorting algorithm. So since you are here in the university, it might be a group assignment. So let's see when it comes. Then we have searching. Again, there are some other searching algorithms as well. Then graph algorithms are also there. We will look into a little bit of algorithms during this session, lesson series as well. Right. Then right at the end of the lecture series, normally I do another session where we discuss the previous year's question paper. So at the end we will do that as well. Then throughout the lecture series, you will have other practical sessions, right? Today, I think today morning session, this session is a practical session. Even though I use it for a theory session, it is a practical session. Because we still haven't started the practicals because I haven't even started the lectures yet. So once we move on with the lectures in 1-2 weeks, we will start the practicals. Right, so let's go through the introduction. So these are the things that we are going to discuss in today's session. What are data structures, abstract data types, what are algorithms, and real-world modeling. Right, so this is for today's lecture as well as for the next lecture, because algorithms we are going to discuss in the next lecture. Right, so first of all, you have to know what software engineering is. Software engineering. Software engineering is the study of ways in which to create large applications based on the needs and requirements of end user. So software engineering is engineering a software or developing a software, right? So here we develop a software based on the needs of the user, right? We develop a software based on the needs of the user. So the needs and requirements of the user. Okay. So this involves the full life cycle of a software project. So you gather the requirements, you design the algorithm, and then you develop the software. So that is basically the smallest cycle. Right? Gather requirement gathering, designing, and developing. Then specifications, requirement gathering, design, verification, testing, and maintenance. These all comes into the cycle. Okay, so that is the basis. Then to develop a software, normally we develop a software to a real world problem, right? Because here the end users are people and they have problems to solve, and they ask us to develop a software to solve their problems, right? End users la කියන්නේ මිනිස්සුනේ. End users ලට ප්‍රශ්න තියෙනවා. ඒ ප්‍රශ්නයක් මොකක් හරි අරගෙන ඇවිල්ලා අපිට කියනවා මේකට සොලියුෂන් එකක් හදලා දෙන්න කියලා. ඩෙවලොප් කරලා දෙන්න කියලා. එතකොට අපි software එකක් ඩෙවලොප් කරලා දෙනවා එයාලගේ ප්‍රශ්නෙට. So at the end, we have developed a software to solve a real world issue. Got it? Then it is important to understand that the subject of data structures and algorithms is concerned with coding phase. Yes, it is concerned with the coding phase of this cycle. We have requirement specification or requirement gathering, we have design, and we have development phase. So this data structures and algorithms comes in the development phase. The use of data structures and algorithms is the nuts and bolts used by programmers to store and manipulate data. Now, what is data structures? Data structures are used to store and manipulate data. Easy ways to store and manipulate data. Again, we have a real world problem. So according to the real world problem, the way to store and manipulate data may change. Right? Different ways to store and manipulate data. So we have different ways to store and manipulate data based on the problem. Then to store and manipulate data in different ways, we have different data structures. Right? So, you know, data structures comes in the, where is the development phase? I have missed that totally. So after this design, we have the development phase. In the development phase, we have data structures and algorithms. Right? Okay. So to store data differently, we have different data structures. Okay, what are data structures? Data structures are ways in which the data is arranged in the memory or in the hard disk. The data structure is a way to manipulate memory, right? A way to arrange your data in the computer memory or in the hard disk. Right? Memory එකේ data arrange වෙන්නේ කොහොමද කියන එක තමයි data structure එකකින් කියන්නේ කියලා පෙන්නන්නේ. In computer science, data structure is a way of storing data in computer so that it can be used efficiently. Right. So in other words, data structure is a way of storing data in computer so that it can be used efficiently. අපිට ඕන වෙලාවට අවශ්‍ය වෙලාවට අවශ්‍ය විදිහට data ලබා ගන්න store කරලා තියාගන්න ලේසි ක්‍රමයක් තමයි data structure එකක් කියලා කියන්නේ. A carefully chosen data structure will allow a more efficient algorithm to be used. So algorithm, what is the meaning of algorithm? Algorithm means a step-by-step instruction set. A step-by-step process. Like how to make a tea. How to make a cup of tea. Right? We have a step-by-step process. Right? Likewise, to write efficient algorithms, data structures are used. And a well-designed data structure allows a variety of critical operations to be performed using a few resources. At few times, so resources in data structures or in algorithms, the resources means the time and memory. Right? Time and memory. Memory means the same. Right? So using the fewest possible resources, how to manipulate our data. That is what the data structures do. Right, so data structures include arrays, linked lists, queues, trees, graphs, stacks, tables, and there are some more as well. But during our lecture series, we will learn arrays, linked lists, queues, trees, graphs, and stacks. And we are not going to go into tables. So these are the things that we cover in this section. So the data structures can be implemented using abstract data types. Now let's see what, before looking at the abstract data types, we will look at what are the different data structures, and then let's move on to the abstract data types. Right, so first of all, we have the array, which is the basic data structure. Arrays. You have learned arrays in programming, right? And for the 9 ICT students also, they have a programming course, right? So I think they have learned arrays there. So normally we represent an array like this. Array is a collection of data of same type. Right? Collection of same type data. And we can use a single name to address this data. So let's say we have an integer array named numbers. Let's assume the type of the array is an integer and the name of the array is numbers. Type of the array means in each, now again, 1, 2, 3, 4, 5, 6. Okay, the size is also 6. So integer size 6 array named numbers. So integer means each of these space can hold an integer. Each of these box can hold an integer value. That's what the integer type array means. And since we have 6, since the size is 6, we have 6, we can store 6 elements. So 6 integers in our array. Right? So we start from, so when number in the arrays, we start from 0. This is the 0th index, first, second, third, fourth, and fifth. And we call these indexes. Index 0, index 1, 2, 3, 4, 5, likewise. Right? So if our size of the array is 6, then we have indexes from 0 to 5. If the size is 6, 0 to 5. If the size is 10, we have 0 to 9. Right? If the size is like 13, we have 0 to 12. Likewise, if the size is n, then we have indexes from 0 to n minus 1. Got it? Okay. Then inside each box here, each index, we have integers. We can store any integer. Any integer is possible. Right? So when storing these integers, we can directly talk to these integers separately. Using the name of the array, we can directly talk to these values, elements. Now we call them elements. Elements of the array. 1, 2, 3, 4, 5, they are indexes. And inside the indexes, we have elements, array elements. Right, so we can directly talk to them. We don't have to go from 0 to 3. We can directly talk. So if we say number 3, it means this one directly. And so if we assign a different number, different value to number 3, let's say 68, then this value will be changed to 68. And that can be done directly. Right? We don't have to go from 0 to 3 to find where our item is. Right? That is really important. Keep that in mind because that is not there in linked list. In linked lists, we cannot directly talk to other nodes. So this is basically the array. Clear? Okay, then the next one. Next one is the linked list. Linked list. I will discuss the basic linked list here. There are few different types of linked list. I'm going to discuss the basic one. So in the linked list, now, sorry, I have a little more to add here. Now, when we look at the memory, in memory, when an array is created, array should be situated in consecutive memory location. All these numbers, the whole array should be stored in consecutive memory location. What do you mean by consecutive memory location? Memory locations that are situated near each other. එක ළඟ තියෙන memory location කියලායි කියන්නේ. Consecutive memory location. Right? Arrays should be stored in consecutive memory location. Okay, arrays should be stored in consecutive memory locations. That is really important. In linked list, that is different. We don't have to store them in consecutive memory location. A linked list is a set of nodes. Right? So we represent them like this. This is a node. Right? We have multiple nodes and we connect them using pointers. Each node has a place to store data and a place to store a pointer to the next node. Each linked list node has a space to store data and a space to keep it pointed to the next node. Okay, so what happens here is we have the data here Inside the data, you can store any type of data. It can be an integer or a character or whatever. Again, like here we use integers, we can also use integers to this one as well. So if this is an integer linked list, then each node, these are nodes, each node will have the ability to store an integer, a single integer. හැම නෝඩ් එකකටම integer එකක් store කරගන්න පුළුවන්කම තියෙනවා. අපි integer විදියට හැදුවා. Right? So here we can store an integer, and then we have a pointer to the next node. We have a space to store the data and pointer to the next node. In this node also, we might have an integer value and again a pointer to the next node. This one also, we have an integer and a pointer to the next node. If that is the last node of the list, then the next pointer is null. And this is our list. And how do we identify the first node of the list? To do that, we have a special pointer. We have a special pointer called the head pointer. Head pointer shows us the starting point of the linked list. Right? Head shows the starting point. And each node has a data section and a next pointer. So when we look at the memory here, in arrays, we know we have to store them in consecutive memory locations, in near memory location. But here, that's not the case. We can have 45 here, maybe 68 here, and maybe 35 here. We don't need consecutive memory location. What we need is, we need a connection. Now, this is our head. And head should point to the next node. And 45 should again point to the next node. Right? No matter where these nodes are, we need to have pointers. And we'll look into each of these data structures later on while we are doing the actual lectures. Until then, keep it in mind that these does not need to store in the same memory, consecutive memory locations. So this is the basic linked list. So we will discuss 4 different types of linked lists throughout the lecture series as well. Keep in mind, this is the array, this is the linked list. Then we have a queue. Queue means, you know, when we in the, I mean, in Sri Lanka now, there are a lot of queues, right? We have a queue for petrol, gas, I don't know, diesel, and anywhere we see, we see queues. And inside the university also, when you go to the canteen, you have a queue. Right? In the ATM outside, we have a queue there. So that is the normal general scenario, a queue. Right? You can see that everywhere. And when that queue is represented in a computer, that is again a queue data structure. That becomes a queue data structure. Right? So let's say in the ATM, we have a queue. Right? So when someone joins into the queue, where does that person come to? If this is the queue, if this is the first person, and if this is the last person, then a new member comes and joins the queue. That member joins at the end of the queue. When someone new comes in, they join in at the end. Right? And when someone leaves the queue, who leaves? After successfully completion, the first person leaves the queue first. After he takes the money, he or she leaves. Right? So the queue goes this way. When someone new comes in, they join in at the end. When someone leaves the queue, the first one leaves the queue. That is the theory behind the queue in computing as well. Right? When someone comes in, so I will represent the queue using a linked list here. When a new node comes in to join, that node will be added to the end of the queue. Right? When we remove some data, we remove the head. After redirecting head to the next node, we remove the head. When we add a new data, it will always go to the end of the queue. Okay. And we call these queues first in, first out data structure. First in, first out. First one who comes into the queue will be the first to go out. Right? First in, first out. So this is a first in, first out data structure, a queue. Okay. Right. So that is the queue. Then we have stacks. Stack. What is the stack? In real life, We can have stack of books. We can have stack of plates, stack of coins. Right? Stack of books means we have a set of books on top of each other. Like this. I don't know. Yeah. Right. We have a stack of books. And stack of plates. In the canteen, we have a stack of plates. Right? So now in a stack, what is the difference? In a queue, you know, the first one who comes in will be the first one to leave. But in a stack, what happens? When a stack of plates is standing like that, when you go to the canteen, you take the first plate, right? You take the topmost plate. Right? Take the topmost plate. And when you put a new plate, then do we put it at the bottom or in the middle? No, normally we put the new plate on top of this. Right? So in a stack, what happens is the first one that we put will be at the bottom of the stack. මුලින්ම අපි තියෙන ප්ලේට් එක තියෙන්නේ ස්ටැක් එකේ යටම. ඊට පස්සේ අපි අලුතෙන් තියෙන ප්ලේට්ස් අපි ඒකට උඩින් තියෙනවා. Then when someone comes in, when something goes out of the stack, the topmost plate will go out. මුලින්ම අයින් වෙන්නේ උඩම තියෙන ප්ලේට් එක. Right? So the last plate that we put onto the stack will be the first to go out of the stack. Last that we put in will be the first to go out. Last that we put in will be the first to go out. So this is a last in, first out data structure. Queue is a first in, first out. The first one who comes into the queue will be the first to go out. And stacks, the last thing that we put on in the stack will be the first to go out. Right, so we normally represent a stack using an array. Right? And for the ease of understanding, we normally draw the array in the vertical position, because that will represent the stack, the normal behavior of the stack. Right? Again, let's say this is an integer stack that we are going to put in integers into this stack. When a new integer comes in, we push it into the stack. Let's say we have 6 down here, 18, 23. And when we put something in, when we put 32 in, that will go to the topmost position of the stack. Right? Now this is the top of the stack. Then when we take something out, this topmost value will be the first to go out. Right? The last thing that we put in will be the first to go out. That is the principle behind stacks. Okay. Right. Just get a brief idea about these things. We will furthermore discuss everything in future lectures. So even if you don't get anything, if you don't understand anything, just let me know, okay? We discussed about the arrays a bit, linked list, queue, and stack. Next, we have tree, the tree data structure. So when you look out the window, you can see trees. Right? They are natural trees. In a natural tree, we have the roots at the bottom. Right? I don't know how to draw. We have roots here at the bottom. Let's say these are roots. Roots at the bottom. And at the top, we have the leaves. Right? We have leaves at the bottom. Sorry. At the top, we have leaves. At the bottom, we have roots. But in a tree in computing, we have the root at the top. We have the root at the top of the tree. And then at the bottom, we have leaves. So this is the tree in computing. Right? We call this the root. So normally a tree in computing will have a single root node, and these are the leaves. So normally we call these, so let's say A, B, C, D. So B and C are children of A. We call B and C children of A. A ge children la. Then parent of B is A. B ge parent tamai A. C ge parent of A. D ge parent of A. Okay. So likewise, if any node doesn't have a child, at least one child, then they are called leaf nodes. Leaf nodes or leaves. Okay, leaf nodes or leaves. So basically, a tree in computer science is an upside down real world tree. ඇත්ත ගහක් අරගෙන ඒක ඔලුවෙන් හිටෙව්වහම ඒක තමයි කම්පියුටිං වල තියෙන tree එක. root එක උඩ තියෙන leaves යට තියෙන. Okay. Right. What else? We have graphs again. This is another data structure. We call them graphs. Graph is it is not just a tree. Now here a tree has a root and it kind of has a hierarchy. Right? This has a hierarchy. පිළිවෙලක් තියෙනවානේ. Top to bottom යන පිළිවෙලක් තියෙනවා, right? But here in graphs it doesn't have a hierarchy. Again, it's a set of nodes connected with each other. but it doesn't have a hierarchy. This is a graph. Again, we call these nodes, they are also nodes. One is a node and multiple of these are nodes, and they are connected with each other. Okay. So this can be considered as like a road map. These nodes can be cities, different cities, and we have roads connecting to multiple cities A and B, and the distance of these roads can be a weight of this road, right? Maybe 17 kilometers. Likewise, this can be represented anything. This can represent anything. So that is a graph. Now look at the difference between a tree and a graph. Tree, we had a particular hierarchy. We have a flow, right? Flow එකක් තියෙනවා tree එකක. But here the graph does not have a flow. It doesn't have a flow. Right. Then after all these searching and sorting, we have searching and sorting algorithms to discuss. Searching means there are different ways to search a particular value in a data structure. මොකක් හරි data structure එකක අපි කියමු එක tree එකක් වෙන්න පුළුවන්. Maybe it's an array. Maybe it's a linked list. I don't know. For anything, to search a value inside, let's say we are searching 6. To search this value 6, there are different algorithms. They are called searching algorithms. මොකක් හරි දෙයක් search කරන්න හොයනවා. අපි මොකක් හරි value එකක් මේ data structure එක ඇතුලේ තියනවද කියලා හොයනවා. තියනවද නැද්ද? Searching. Right? We are searching for a value whether they are in the data structure or not. Okay. So for searching, we have different algorithms. Again, for tree searching, we have different algorithms. For arrays, we have different algorithms. For linked list, again, there are no multiple varieties of algorithms there, because we kind of have a flow for search, right? So these are the different searching algorithms. We will learn them in future as well. Different ways to search in different data structures. And sorting means it is not searching. I mean, so in searching, what we do is we search for a particular value. But in sorting means we rearrange the data values in some order. Right? Sorting means in integer sorting. So let's say we have an array 6, 7, 8, 9, 10, 11. We need to arrange them in an ascending order. We need to arrange them in ascending order. I don't know. I have missed this. Ascending order. Then we need to rearrange these numbers, right? So that is what we call sorting. We sort this array And the output of the sorting becomes the sorted array, which is the ascending order. Sorting කියලා කියන්නේ මොකක් හරි පිළිවෙලකට rearrange කරන එක. Normally we rearrange them in the ascending order. So this is the sorted array. This is the unsorted array. For sorting, we have a lot of different techniques, different ways to sort. මේ sorting කියන එක කරන්න විවිධ ක්‍රම තියෙනවා, විවිධ algorithm තියෙනවා. ඒව තමයි bubble sort, quick sort, merge sort, selection sort, insertion sort. There are a lot of different algorithms for sorting. We will learn these different algorithms and the advantages of each algorithm. Okay, so these are the things you are going to learn throughout this lecture series. Starting from arrays, we will learn linked lists, queues, stacks, trees, graphs, searching, and sorting. Right? Okay, so before starting with all these things, we need to know what an abstract data type is. In computing, an abstract data type is a specification of a set of data and a set of operations that performed on that data. Not only the set of data, but also the operations that perform on that data. Right? Independent of various concrete implementations. They can have various independent implementation. The definition can be mathematical or it can be programmed as an interface. It can be a mathematical definition, it can be a program definition, it doesn't matter. Interface provides a constructor which returns an abstract handle to new operations. Again, these things, you will learn what this means while we are doing the practical session. Like we can have an interface that just describes what should happen inside this data structure, right? Or else we can actually implement what should be there inside the function. Yeah, a way of looking at data structure focusing on what it does without considering how it does the job. Abstract, that's why we call it abstract. We don't care what happens inside. How it does the job is not important, but we need to do this to this job, sorry, this data structure. A stack or queue is an example of abstract data type. Both stacks and queues can be implemented using an array. Stack can be implemented as an array, sorry, using an array, and also queue can be implemented using an array. It is possible to implement stacks and queues using linked list as well. But that shows us the abstract nature of stack and queue. Stack can be implemented using arrays. Queue also can be implemented using arrays. In the same manner, they both can be implemented using linked lists. But how it differs comes in when we look into the program itself. Right? How it works is different. Stacks and queues, how they work are different, right? but both can be implemented using arrays or linked lists. So that is the abstract nature of these data structures. Then what are algorithms? Algorithm is a procedure, a software program used to manipulate the data in these data structures. මේ data structure වල තියෙන data manipulate කරන්න යොදා ගන්න procedure එකක් තමයි algorithm එකක් කියලා කියන්නේ. Right? Or algorithm is a finite set of well-defined instructions for accomplishing some task which, given an initial state, will terminate in a defined end state. So it does have an end. An algorithm does have an end, and it has some task to finish. It's a well-designed, defined instruction set to accomplish a task which has a defined end. පැහැදිලි අවසානයක් තියෙන මොකක් හරි ටාස්ක් එකක් කම්ප්ලීට් කරන්න හදපු හොඳට ඩිෆයින් කරපු ඉන්ස්ට්‍රක්ෂන් සෙට් එකක් තමයි algorithm එකක් කියලා කියන්නේ. Right? I know the word is heavy. Algorithm, the word is very heavy, but it is not that hard. It is a simple theory behind it is simple. You don't get confused. The computational complexity and efficient implementation of the algorithm are important in computing, and this depends on suitable data structures. Computational complexity means time and space. How much time it takes or how much space does it take? Each algorithm, these algorithms. Right? We check the time complexity to identify the efficiency of this algorithm. And it mostly depends on the suitable data structure. Algorithms complexity, computational complexity depends on the suitable data, depends on using the suitable data structures. Okay. Algorithms are used to manipulate the data contained in these data structures. When we look at a data structure, we need to manipulate the data there. Simply having those data in the data structure is not enough. අපි මොන හරි data set එකක් අරගෙන ඒක tree එකකට දානවා. tree එක එහෙම තිබ්බා කියලා අපිට ඇති වැඩක් නැහැ. අපිට ඒ dataත් එක්ක ගනුදෙනු කරන්න ඕනේ. We need to work with this data. Right? So we need to add, we may need to insert new data, we may need to delete data, we may need to search for a specific item, right? Likewise, we need to do some tasks with this data. Then there's the place where algorithms comes in. How to insert new data? We write an algorithm to insert new data into these data structures. We write a separate algorithm to search for a separate item. We write another algorithm to delete a specific item. Right? Likewise, to manipulate data contained in the data structures, we need to write algorithms. So commonly used algorithms include searching for a particular item, searching, sorting, iterating through all the items in the data structure, going through and inserting, deleting, printing maybe, right? So there are multiple different algorithms that we need to write. So for each data structure, those algorithms differ. එක data structure එකට අපි මේ ලියන algorithm එකින් එකට වෙනස් වෙනවා. searching වෙනස් වෙනවා, sorting වෙනස් වෙනවා, iterating ඒ හැමදේම print කරන එක, insert කරන එක, delete කරන එක, ඒ හැමදේම වෙනස් වෙනවා algorithm එකෙන්, sorry, data structure එකෙන්, data structure එකට. Right, so there are a lot of things to learn in this course. Right, I hope you are ready with it. So it is easier when we are in the same place. If we can conduct the physical lectures, that would be the best. Okay, then these are some of the places where the data structures are used for real world data storage, student records, like stack of index cards likewise, and as a programming tool and real world modeling, right, to implement a real world situation in a computing situation, like a task in a project, queues at a clinic, likewise. So from each specific data structure to, yes, I know you are in the university. I didn't conduct it today physically because I don't know how many students will be there, because we have IT students as well as ENT students. So I hope there will be like, there might be like 140 or 150 students. We don't have a lecture hall to conduct a lecture for that much. That's why I conducted the first lecture like this. Right, so since it is 44, then I don't think it would be a problem. So I will arrange from next session onwards. I'm going to conduct it in physically. Right, you have another lecture tomorrow, right? Tomorrow 3 to 5. I have arranged it to have as a physical lecture. All right, so that's it for today. That's the introduction, and I think we have discussed a lot for today. I'm not going to add anything more. So next one is about algorithms. We will conduct that in the next session. So probably, I think we do have theory session tomorrow. No? Yes, it's 3 to 5 Wednesday. I have arranged a lecture hall. I cannot remember whether it's L1 or L2. However, I'm going to conduct tomorrow's lecture physically. So come to the university from 3 to 5. I'm going to conduct the lecture in L1 or L2. I don't know. I cannot remember. Okay, I hope to see more than 41 there. Probably now, I think since you are in the university, some of you might have joined through a single account. Maybe that's why we have only few people. I don't know. So, however, come to the university tomorrow, and at least let's see whether we can fit you all into a single lecture room. And if it is not possible, I don't know what to do. I have informed that to the ARFs and the head of the department as well, Shanta. I have informed him. I think probably from next week we will have a different, classroom for these huge classes. Okay, then I'm going to stop here for today. Do you have any other questions other than that? Anything else?